Hello, everybody, and welcome to this month's Bag webinar. And I'm very pleased that I have two of my colleagues with me today. Um, Juanita Barrera is our Senior Sustainability Advisor, and she's going to be presenting the state-level agricultural data collection and effects on life cycle assessment that was developed by many members of our team. Juanita is based in Bogota, Colombia, and her work for Earthshift Global is primarily focused on life cycle assessment studies for a range of clients. She holds a Master's of Science in Industrial Ecology from the Universities of Leiden and Delft in the Netherlands. And to give your questions, Joel Bonales Revuelta will be collecting them from you, and we'll ask Juanita on your behalf at the end. So welcome, Juanita.
Thank you. Thank you, Holly, and thank you, everyone, for being here with us today. As Holly mentioned, my name is Juanita Barrera Ramirez. I'm based in Bogota, Colombia. I'm a senior sustainability advisor at Earthshift Global. I have been with the company for almost 5 years now. I'm working in the life cycle assessment world for around 7 years now. The results that I will be presenting today are from a project that was commissioned by ecoinvent and that we, as a Earthshift Global team, developed. So I have the honor to present the results of this study, but I want to make sure that we all know that this is a team effort. So the webinar, as Holly also mentioned, the name is State-Level Agricultural Data Collection and Effects on Life Cycle Assessment. So as LCA practitioners, and in general, anyone who wants to calculate the environmental or a system face the data collection part. This phase could be the most time and resource consuming, but yet is one of the most important, because the better the data you have, the better your system or your product will be represented in terms of the environmental impacts. Greenhouse emissions from agriculture, forestry, and other land use were about 21% of the total greenhouse emissions in the last years. So this is why it's important to get better data on agriculture. In ecoinvent 3.8, some of the US agricultural products are available as a national average. So in this project, we collect data, calculate impacts of 4 crops on a per state basis. So we move from having national average to a state average data. And the crops that were included in this project were corn or maize, soybean, potato, and sweet corn. The system boundaries of these data sets are cradle to farm gate, which means that all the agricultural inputs, such as fertilizers, pesticides, seeds, were included, as well as the field operations and machinery needed for this. Emissions to air, water, and soil also were included, and let's say like the functional unit or the reference quantity was 1 kilogram of each of the agricultural products. So 1 kilogram of soy, 1 kilogram of corn, 1 kilogram of sweet corn, and 1 kilogram of potato at farm. And please keep in mind that we were collecting all this data for building those data sets that are now available on ecoinvent 3.10. So now that we are clear on the system boundaries, another important question to answer was, okay, what are the states that are going to be included per crop? Are those the same for all the crops, or like how we decide this? So first answering, one of the questions, the states are not the same for all the crops, and we took these maps from the USDA, the United States Department of Agriculture, and identified the top state producers per crop. So if we look at this image for corn, the darker the green, the higher the production. So for corn, we are including Iowa, Indiana, Illinois, Nebraska, Minnesota, South Dakota, and Wisconsin. For soybean, the states included were Iowa, Indiana, Illinois, North Dakota, Minnesota, Nebraska, and Ohio. For potato and sweet corn, the production map, as we saw for corn and soybean, were not available. So we took the one that you are seeing now that present the harvested acres and identify the top producer states. So for potato, we include Colorado, Idaho, Minnesota, North Dakota, Washington, and Wisconsin. And for sweet corn, California, Florida, Minnesota, Oregon, Washington, and Wisconsin. So we had crops, states, system boundaries. But then next question, how to prioritize the data during the data points during the data collection. So what we did here is we use the available data sets on ecoinvent, and this is just an example on ecoinvent 3.8 for all the crops, and identify the top contributors. So this is an example. We took a wide range of environmental impact categories. And this one we are showing just 6. The first 3, human health, ecosystem, and resources, are the endpoint recipe, global warming from IPCC, cumulative energy demand, and water scarcity from our to identify the top contributors, the stages or the inputs that contribute the most. And we took this approach considering not just one category, but a range, because help us to identify trade-offs as well. For example, if we just look at the ecosystem, we'll say, okay, direct field emissions is the most important. But then when we have a broader picture, we say, okay, fertilizers, machinery, and operations are the 3 top contributors. Fertilizers, or under the category fertilizers, is included the upstream impacts of the production of the fertilizers on machinery and operations. As the name is saying, the machinery that is needed for fertilizers application, pesticides, tillage, and direct field emissions that are caused by the use of fertilizer, pesticides, among others. And then the next steps was to identify the data sources and models for calculating the emissions. So for the emissions, we had the guidance from ecoinvent, but for identifying the data sources, we did a literature research focusing on primary data sources. So for the yield, agrochemicals and agrochemicals applied, so fertilizers and pesticides, and irrigation, we took the data from the National Agricultural Statistics Service information, and this center, what does is conducting hundreds of surveys and census every year, and prepare reports and statistics covering a lot of aspects of U.S. agriculture. So we went there and retrieved all the data for yield, agrochemicals, irrigation. Then for the seeding rate, we rely on literature. For the manure, we took this data from the Agricultural Resource Management Survey. For the operations and operations machinery and energy use, we use enterprise crop budgets and farm survey data that is reported on the extension offices. And for the tillage practices, we use the data that is reported on Optis, the operational tillage information system, and they use remote sensing data to provide data on tillage. Then this chart presents a summary of the emissions and the model we use to calculate each of them. This is kind of like a summary, but all the details can be found in each of the data sets that we develop under this project. So just a short recap before moving into the results and the what is new. We include 4 crops: corn, soybean, sweet corn, and potato, each one for at least 5 states, and we gather all the data on a per state basis. And in some cases, as for liming, we had to rely on county data level. So we prioritize primary data for being these data sets as representative as possible. So now we're jumping into the comparative results. So how the results from on a per state basis compare to the US average. And here we are seeing the results for, the comparative results for soybean. So results are presented relative to US average production. And this data set, the average one, is available on ecoinvent 3.8. So what we can see here is that the trade-offs are presented. In some categories, results increase, so the environmental impacts increase, and in some other decrease. So if we look at human health, the trend is that the impacts are increasing. If we look at ecosystem, except in North Dakota, ecosystem impacts, are decreasing. Resources, the trend is all are increasing in all the states. And if we look at global warming and water scarcity, that are 2 of the top categories that we analyze and that we are familiar with, we see that in all the states for global warming, as compared to the national average, impacts are reduced, decreased. So this helps us to understand the importance of gathering better data and representing as much as possible our system. Same happens with water scarcity. We see in states as Iowa and Ohio, in which little irrigation is used, that the impact is decreased as compared to the US average. So it's important to highlight that the agricultural practices, tillage, quantity of fertilizers, pesticides, are different among the states. Yield is affected as well. So environmental results change from one state to the other. And now, if we look in more detail, the contribution for some of the states, and we are seeing here results for soybean. So in the contribution analysis, the trend of the 3 top contributors remain. So we have direct field emissions, machinery and operations, and fertilizers are still the top 3 stages or input that contribute, that the top contributors among these 6 categories, except in water scarcity, where irrigation plays a more important role. But the three top remain the same. And if we look results for Indiana, top three remain the same, and same is true for Ohio. What is changing from one state to the other, if we look at the contribution analysis, is the percentage in which each of these three is contributing. So, quick example, direct fuel emissions in human health in Iowa represent almost 15%, in Indiana around 10%, and in Ohio 10%. And in water scarcity in Ohio, that was one of the states that I mentioned that use less water for irrigation. We see that fertilizer production plays a more important role, or is a top contributor on the water scarcity. So now, going a little bit deeper into what is new besides what we already discussed, that is the fact that we are moving from national average to a state on a per state basis. Data is the time period we include, we average data from 2014 to 2021. We are considering tillage practices, so conventional, reduce, and no till for the four crops, or the difference applies as in soybean and corn. The field operations and equipment types and field use, and I will go a little bit deeper on this one. The soil characteristics. So for calculating emissions, we took into consideration the pH, the soil organic matter, the weather characteristics. So it's better representing those states. Also for the manure, we make the distinction between the type, if it's liquid and solid, and the animal. And here the data that is available is a little bit older than other data, but is what is available, and we try to capture this in the best way possible. Granular data on pesticides, and I will also go deeper into this one. Also the heavy metal calculation, which in some agricultural products is not being included. Detailed comments, and also I will go or explain further this point, and machinery and operations. So what I meant with granular data on pesticides, this is an example on how the pesticides were captured on the soybean US average. And the one that we see on the right part of the screen is how now is being captured for the, for, I think this one is Iowa. So we are really moving into a more granular data on pesticides. Also, as I mentioned, the heavy metal calculation is included for water, soil, and for water for ground and surface water, and for soil for the agricultural subcompartment. And we follow the Salka heavy metal model, which is the one that is available right now. And now, talking a little bit more about the detailed comments. So we are used to see comments like this one. And this is an example for an emission, for nitrogen oxides emission. So we're familiar with this type of comments in which we are capturing the pedigree matrix numbers and just calculated with the standard method. And now we are moving into more detailed comments. So, and as this is an example, so how much is coming from fertilizers, how much is coming from manure, and what was the model that was followed, and the coefficients and parameters that are considered. So the idea is that this will allow practitioners to trace back calculations. And if you have a change on the manure quantity, you can also easily change the um, the emission. So that's one of the ideas and the advantages of these new data sets, the detailed comments. And also, if you are using as a base one of these data sets for building a new data set for representing your country or your specific project, these detailed comments will allow you to trace back all these calculations. But this is not only true for emissions. We also include detailed comments for inputs, as this is an example for urea. So how we calculate the amount of urea, we base the US fertilizer market share and nutrient composition from the International Fertilizers Association to meet the total nutrient demand for nitrogen, potash, phosphate, and sulfur. And here, here you will have the quantity, the kilograms per hectare, and where this data is coming from. And also you will have, of course, the sources, so you can go back and check there and make changes or adjustments. Also, we have detailed comments for machinery and operations. And in this case, I'm sharing with you one from tillage. So for calculating the tillage, we put the effective passes per year, and also the share of the tillage practices for that state, as we see in here is, and in this example, soybean is 42 reduced tillage, 42 no-till, and 16% conventional tillage. This is for Ohio. So again, advantage, you can trace back and you have all the sources that we use to came to the number that is being presented here and the years that are included. Also, on the machinery and operations, all these data sets were developed for US. Some others as well for like taking into consideration a global and a rest of the world average. But what is really special of all of this is now we have more machinery available for tillage, so we can better represent the three type of tillage: conventional, no-till, and reduced till. We also consider the fuel consumption, so the quantity of fuel per hectare, the number of passes that is needed for fertilizers applications and pesticides, and the percentage of area that is receiving the product. So all of this is new, and all these data sets were based on agricultural extension expert estimates of the annual crop budgets, and also farmer data survey that is available on the extension office per state and per crop. Then also for machinery and operations, for the application of fertilizers and pesticides, we have some more new data sets available. I'm showing those here. And also for harvesting, for planting, we have an extensive, or not an extensive, but more machinery included. So now moving into the end of my presentation to give time for all the questions, is that agricultural practices, as the quantity of fertilizers, pesticides, tillage vary among the states, as well as the land and soil characteristics. This affects the yield, thus affect the environmental impacts of agricultural products. And that was obvious, or we saw this during the presentation when I shared the trade-off that we encountered for soybean, and the same was true for the other three products. Machinery operations, fertilizers, and direct field emissions are identified as environmental top contributors to agricultural products. So that give us a hint on where to start getting better data. And the detailed comments on inputs and outputs of the data sets that are now available on ecoinvent 3.10 allow us as LCA practitioners and anyone who use this database to trace calculation back, adjust when needed, but also go and review all of these sources and learn from that. So thank you so much. And with this, I'm finished my presentation to give a space to the questions.
Thank you, Juanita. And now Joel one of our LCA analysts will answer your questions, will pose your questions for you. Thank you.
Thank you very much. And thank you, Juanita, for such an interesting presentation. We have lots of questions in the chat, so we'll do our best to answer every single one of them. But if we missed any, well, Juanita already shared her email if anyone wants to reach out after this presentation to any inquiries that may still be present. So moving into the questions from our audience, we have this first one, which goes as, with corn and soy in particular, the top producing states just below the ones that you've selected, as an example, Nebraska and Arkansas, can influence the national average considerably because they are within the region where irrigation is far more prevalent. How do you justify cutting off inclusion for just the top 6 to 7 states?
Thank you. Thank you for this good question. So short answer, limited resources. So we had to just select the states that were top producers, and also that in which for the data was available in graded detail. So that's kind of like the reason for selecting only those states.
Thank you very much. The next question goes as, what specifically is the ARMS source for manure application? How specific is this data? State level, crop specific, or animal species specific manure sourcing?
So this data is pretty specific. They report on animal, if it's liquid or solid. However, the data is pretty old. The latest update of this data is from 2015, but we did an extensive research on this, and it was the one that was really better capturing those inputs.
And a related question, does the usage of manure imply organic farming?
No, we are not including organic farming. This is conventional.
Okay, thank you for the clarification. Then another question goes, what does the land use impact represent in the contribution analysis? Foregone sequestration?
Land use is was calculated following the ecoinvent guidelines and does not include foregone sequestration.
Okay, thanks for answering that one. Then, well, someone in the audience wants to congratulate you on this excellent work, and then wants to ask, what were the greatest challenges you faced in the regionalization process?
Okay, thanks for that. This was a project that took us over like 2 years. So for US, it is they have a great level of data in the US NAS web page and statistics. But we face a lot of challenges in the manure quantity and also on machinery and operations. So that is why we went for manure. The data is from 2015, the latest one. And for the machinery and operations, we had to go to the extension office to get better data and more representative. And for specific for sweet corn, the data also was not available on tillage and others. So we have in other for other inputs. So we also have to make some assumptions and interview experts. But all of this is captured in the comments of each data set.
Great, thank you very much. And we have also a couple of related questions. One is, do you have an estimate of how long this data will be valid? Or does ecoinvent have a plan to update them at a specific time?
No, I don't know what are the plans from ecoinvent for updating this data. However, has just been released, so it might take some time to update it again.
And I think you touched some of these, but still I want to share this question. Why did the average data included from 2014 to 2021? Why 8 years and not more or less years?
Well, for 2021, because I don't know if you are familiar with the ecoinvent process to handle data, but the revision process took us in this specific case like at least six months, and the whole project 2 years. So when we start the project, that was the latest data from 2021. And for the and we took these years because for some fertilizers the data before that was not available.
Okay, thank you. So another question, is it reasonable to calculate ammonia emissions from volatilization using the European EPA table?
We follow the ecoinvent guidelines for all the calculations for the emissions.
Great, thank you very much. Another member of the audience wants to know what was the functional unit of the overall project and if the data needed any type of allocation, either physical or economical.
It was 1 kilogram of each product and no allocation was applied at this point.
Great. Thank you. So another for the comparative soybean result, how was the UA average calculated for water scarcity and cumulative energy demand? For cumulative energy demand, the average is higher than all states. Water scarcity average does not seem right either, with only one state slightly higher than the average. I think they are interested in the overall variations between states in key indicators.
Okay, so the US average for soybean, we'll have to review the ecoinvent like guidelines, how they collect and put together this data set. For water, and the same is true for like cumulative energy demand and water. What I can tell you is that we include irrigation, the one that is reported on the USDA, and the cumulative energy demand also is like pretty similar for all the states for soybean. But this is like, please keep in mind that this is just like one example. So can be completely different for corn and for sweet corn. And for the US average, we'll need to check all the details that are reported for that data set in ecoinvent, as we were not involved in that data collection and the process of building that data set.
Thank you very much. Another member of the audience wants to know if, well, these new results assume manure application to field. Do you also consider synthetic fertilizer or compost application, or are those applied to an insignificant amount of fields for these crops?
Yeah, so we assume manure application when it was reported, and also fertilizers, synthetic fertilizers, like the common one. And please remember that this is conventional agriculture. So yeah, we do consider both, not compost, because we didn't find like enough data about that.
Thank you. So also on the soybean impacts, they want to know what impact of direct field emissions have the highest contribution on the ecosystem impact category.
I'll have to like double check. I don't have it on the top of my mind, but I will like share with you what is the top contributor on ecosystems.
Okay, thank you. And on a related note, the audience wants to know if there is a documentation or a public report for accessing this work.
I think you need to have an ecoinvent license for getting all the details that we present on this work. However, the Eco Query now has available like a free web page in which you can go and get some of these details, but not all.
Thank you. Returning to the data collection efforts, could you please provide information on the number of the samples used? How many farms the data were collected from each state?
We don't have that data or like a specific per state per farm. But you can go to the NAS, to the USDA and NAS quick stat web page, in which they report all the details, and they report all the statistics and review the documentation to go deeper on that.
Thank you very much. So also related to data collection efforts, could you find all the data you needed in reports and statistics, or did you have to talk directly to producers or associations to raise some data? If you had to talk to producers, how was the process to convince them to deliver the data?
No, everything was statistics and the extension office and literature in some cases, but we don't interview producers for this project.
Great, thank you. Another question goes as OPTIS or OPTIS, I'm not sure how to spell that, data is only available publicly at watershed level resolution. How do you think statewide or watershed level results are beneficial in terms of targeting conservation? And how can non-governmental researchers access finer resolution data?
Well, for a more granular data, I don't know if we can like contact them and try to ask them, but also on the OPTIS on a per state level is available in terms of the tillage practices. But I know they capture a lot of data, so maybe just contact them directly and asking for the data that you need. I think that will be like the first step on this, as they already have collected a lot of data and it's public available.
Thank you very much. So speaking of tillage, do you have documentation to dive deeper on how those regionalized or how to create the datasets on tillage?
All the documentation is on a per input basis, I would say, but on tillage, what we did, we were lucky because of the Optis already give us the percentage of reduced tillage, non-till, and conventional tillage. But then for linking that into machinery, we went to the extension office. And there is a great resource, which is the Clemson workbook that report a lot of the machinery that is linked to each type of tillage. So I recommend to go to that one to understand a little bit better this tillage world.
Thank you. Very interesting. We have room for a couple of additional questions before closing this webinar. So are machinery and operations inputs such as diesel fuel use primary data, or were rather calculated based on number of passes or activities?
So for machinery and operations, we capture the number of passes, and we kind of like link this to the fuel used per machinery to come to one number.
Thank you. Did the data include capital goods on production of machineries?
Yep.
Good. Another question, is the manure data used specifically for manure applied and to which crop type, or rather on manure produced, for example, number of animal operations per state?
Manure applied.
Thank you. So did the data used vary significantly in terms of granularity, quality, and or availability on a state-by-state basis, or was it fairly consistent?
It was fairly consistent among the states per crop. It varies from crop to crop.
Okay, thank you very much. And we have room for a couple more. So one member of the audience wants to know, out of curiosity, why did sweet corn was included into the assessment?
That is a question for ecoinvent. We were commissioned by them, and they decide sweet corn, potato, corn, soybean. That was their priority.
Thank you. And as terms of closing, well, a member of the audience says his team is also conducting a regionalization project for several sectors in Chile. So would you have some learnings and recommendations you can share, that will facilitate other regionalization efforts around the world?
I'll say what we share here in terms of identifying the top contributors, even if it's not for your country. Just first step is okay. Just go and regionalize and check what are the top contributors and focus their for the collecting data efforts.
Thank you. This is very helpful. And one last question. Well, did you get the machinery and operations data from every state extension office?
For the ones that were available, yes, and for others, we based in the ones that we had available based the others. So it was not available for all, but we tried to regionalize as much as possible.
Thank you. This is great. Well, there are a couple of remaining comments asking for the names of some of the workbooks and documents that we've already mentioned. So maybe we could ask if maybe reaching out an email to Juanita and
Yeah, please reach out and I'll happy to share that information.
okay, thank you very much. This was a very interesting and extensive set of questions, but we managed to answer nearly every single one of them. Again, thank you very much, Juanita, for this very interesting presentation and for answering all of our questions. And we would also like to thank everyone in the audience for their attendance, their questions, and their overall interest in these life cycle assessment related topics. Thank you very much and have a great day.
Thank you, everyone. Bye.